welcome back. It's time to learn about how to factor a difference of squares. And you'll hear me sometimes say that this is a difference of perfect squares. And you'll know if it's a difference of perfect squares if you see one perfect square minusing another perfect square. And it's called a difference because difference means to subtract, and squares referring to each part being a perfect square. So if you see one perfect square minus another perfect square, there's a special factoring pattern that follows. And the way you do it is you take the square root of each part. So the square root of a squared is a, and the square root of b squared is b. So a and a b in each one. And in one binomial, you'll have a plus. In the other binomial, you'll have a minus. So a plus b, a minus b. So that's how you'll factor a difference of squares. So here's an example, x squared minus 64. X squared is a perfect square. 64 is also a perfect square. So I will factor this. The square root of x squared is x. And then I think about the square root of 64. I don't have to worry about this minus because the minus is taken care of in the factoring pattern. The square root of 64 is 8. And I'll have one plus and one minus. Now, if I want to check, I can distribute this out to see if I get x squared minus 64. So x times x is x squared. X times negative 8 is minus 8x. 8 times x is plus 8x. And then 8 times negative 8 is minus 64. So you'll notice x squared plus 8x, minus 8x plus 8x minus 64 does simplify into x squared minus 64. So that does check out, but my factorization of the difference of squares is x squared minus 8, not x squared, x minus 8 times x plus 8. Then sometimes you'll have the constant in front followed by the variable, but it still factors the same way. So you take the square root of each part. The square root of 9 is 3, so I'll have a 3 in each. The square root of x squared is x, so x and x have a plus in one, minus in the other. They do get a little more complicated. Sometimes you have two perfect squares, so 9x squared and 64. But I still notice 9 is a perfect square, 64 is a perfect square, x squared is a perfect square. The square root of 9x squared is 3x, so put a 3x and a 3x. The square root of 64 is 8, and we'll have a plus and a minus. And then they do get a little more complicated even still with whenever we have higher exponents, but we will still keep doing this the same way. So the square root of 25x to the fourth, the square root of 25 is 5. To take the square root of x to the fourth, divide this exponent in 2, 5x squared, 5x squared, and then the square root of 1 is 1, a plus and a minus. And it doesn't matter where you put the plus and where you put the minus as long as you put 1 in each. Then sometimes they like to, use two variables like this one. So again, as long as these exponents are even, you've got perfect squares. So I take the square root of it. When I take the square root with exponents, you're dividing the exponents by 2. So the square root of x to the fourth is x squared. The square root of y squared is y to the first power. So an x squared and a y in each set of parentheses. And then the square root of 1 is 1. So 1, 1, plus, minus. There we go. All right, have fun with this.